here's our GPIOs along this edge, and here are this is the connector, the interface for them, right? So your GPIO 0 through to 7 on the silk screen, and you've got grounds on this side. Now, in the lab, what I'll do is you'll have the probes, but I'll give you a couple of wires that you can use to put in here, okay, so you don't damage them. If you're unsure, don't do it. Please speak to the tutor. These are all I have, and they're very fragile, but make sure you do turn them off and not do what I'm about to do. Okay, I built them, I can break them. So you can see we've got that sitting in there, right? Everyone happy? Okay, so what I'm going to do now is I need to, actually not really what I want, but anyway, I need to connect a probe. So I've got my probes, proper probes, okay. At the moment, that is lead 4 flashing. I'm just going to pick lead 4. So spring clip, sorry, my eyes are bad. 0, that's ground, that ain't gonna work either. 0, 1, 2, 3, I'm assuming that's 4, I cannot see it with my eyes. And then I need a ground, so ground is these back, ground's gonna be, don't do this, you have proper wires. Somewhere like that, all right? You can tell I do this at midnight, right? So I've got that connected, ready to go. All right, I'm just very carefully bringing it back here. Okay, so, and then I'm gonna plug this in. Okay, cool. Now, if I move that slightly over, can we see, yeah, we can see enough of the screen. Cool, what does everybody do in this instance? What's the first thing everyone does? This button. What are we not doing? We're not pressing that, okay? Default setup if you're gonna press anything. All right, and it ends up doing that. Okay, so we've got our probe, we've got our light source here, flashing lead 4. What do we notice? What do we see? Oh, actually, do you want me to turn, is that light a problem? I'm just gonna do this just for a second. Hopefully it's okay. Is everyone all right with that? Is that okay? Or is it better with the light on? So I've got bad eyes. No, I'm getting that reflection right in the top corner. Okay, just momentarily, let's turn that off. Cool, all right, so here's my scope up and running. You can see that I've got 5 volts per division here, and my time base is 100 microseconds per division. That means there's 10 divisions across the screen. This sweep is 1 millisecond. Is that right? Everyone happy with that? 1,000, 100 times 10? 1,000 microseconds, which is 1 millisecond, okay? So it takes a millisecond for that to draw. What do you notice about our waveform? It's changing, yeah, but at the moment we're going from -20 to +20 volts. What's the I/O voltage on our board? What do these processors run at? 3.3. So we need, I mean, you don't have to, but you know, we can zoom in a bit, or we can increase our vertical resolution, our resolution. At the moment, I've got it set at 1.0 volts per division, okay? Now, this, you can't see it, it's pretty bad. That's indicating 0. Do we want AC or DC coupling for this design? When do we use AC coupling? What does AC coupling do? Removes the DC offset, okay? We want DC coupling for this design. AC coupling is effectively a high pass filter. DC coupling is you're getting everything including the DC voltage, right? Okay, so everyone's good with that? All right, but our time base is wrong because we're expecting square wave, we can see it oscillating. So what I'm gonna do, I'm just gonna turn the lights back on. So we'll lose that corner of the screen, but that's okay. Let's just go to load to give it slightly a little bit better. Okay, cool. Now we want to adjust our time base. So on these scopes, and it's the same with the ones in the lab, this is just an older one, okay? The black ones are identical, except this has got a few more features. Horizontal, so let's adjust horizontal. Okay, so what do we want to do? 1 millisecond per division, 2, we're getting there, 20, 50. Now, keep in mind, that's 50 milliseconds per division. So to scan that entire screen, is going to take 10 times that. So you'll see the trace update very slowly, okay? The scope's running fast, it's running at 5 gigasamples per second, all right, but it can't, you know, it's a slow waveform. If I pick a different LED running at a different frequency, it will be faster, okay? Everyone good with that? Happy with that. Now, a couple of things. Trace is moving all over the place, right? Why?
Too long to trigger? The time base won't let you trigger?
Yep, so we've got a trigger issue. At the moment, my trigger is at the bottom. You can see the little T here, okay? So if we grab our trigger's here, we can bring it up to where we want it to trigger, okay? Now, it's still moving around a little bit because it's looking for the first edge, okay? Or the first time we transition across that line. Now, one way you can fix that problem on these scopes is you can put them in single shot, and when you single shot, you'll get, when it's triggered, you'll get the waveform drawn, and that is it. It'll scan the entire screen. Done. It stops triggering. You can do it again just by hitting single, and it waits for your waveform to cross that trigger, and there you go. Okay. These scopes also have this one here. Okay. This gives you a. No, it doesn't. Not that button. Well, it does. Just not. It gives you a delay, so you can actually move that waveform. So you can set it before or after, okay? You click it, it goes 0. Also in your trigger menu here, you can see whether doing triggering on channel 1 with a rising edge. You can decide where you want to do that. One thing to watch with these scopes is they do have touch screens, which are by default on, and I hate them, because if you get near the screen, they do things like this. So I always turn them off, okay? So it's up to you, and I hate fingerprints on screen, so we'll turn them off. Cool. Up top right-hand corner, see we've got 1.71, that's my trigger level. Okay, 1.71 volts is where I'm triggering. Now, this looks like a waveform, great. If we go back to channel 1, remember we said we're running at DC coupling and an input impedance of a meg ohm. You want it on a meg ohm because otherwise, you're providing a 50 ohm load to the I/O pin, and it will not like that. It'll work, but it won't like it. It'll get hot pretty quickly. If we change this to AC coupling, just to show you, it's still at a meg. What's going on? All I did was change the coupling mode. No tricks. What does that look like? What does that remind you of? That's a capacitor discharge curve, charge discharge curve. So the AC coupling is actually treating it, that square wave is, because the scope's trying to remove that DC coupling, right? Trying to remove the DC component, yeah? Well, when it does, this is what actually happens, all right? So you've got to be really careful about how you set these things up. Just think, in the digital world, we typically only work with DC coupling. If you're in power or comms, you AC coupling, okay? But we typically run DC. Right, waveform. Frequency, how do we determine frequency? How do we do it? Options. You guys are really lucky with these because I have an analog scope. How do you work frequency? What's frequency? 1 over the time? 1 over the period? Okay, so we can do this a couple of ways. We're running 500 milliseconds per division. If we grab the cursor, now I can't see this particularly well, not just because of where I'm standing. So I've lined that up here, okay? That's a square edge, it's so fine you can't see it, okay? Right, so if I want to work out frequency, my waveform goes from here to the next rising edge is there, right? So what have I got? 500, 1 second, 1.3 seconds, give or take. It's not very accurate, is it? Okay, so what you can do, I mean, you can do that on these cursors, okay? You end up with all this. What you're interested in is in manual mode, channel 1, or source is X1. If you press the button there, you can turn the cursors on or off. We don't want, and you can use the rotary dial here, we don't want Y1 and we don't want Y2. We're only interested in X because we're looking at time. Y is voltage. Make sense? Time versus voltage. So let's go back to here, back to cursor 1, back out of that menu. Now what you can do, this gives you control of the cursors, and I can move that cursor. One really nice thing with these scopes is you can do tricks like this. No, you can't. You can do that. Oh, no, it's gone too far. That one. So you can actually zoom in and effectively set that trigger right on the edge, wherever you want it. Okay, like cursor. Sorry. We'll zoom out. Okay. Now it's got a retrace because of the speed we're running at. There's our second one. So now cursors. We want to go to cursor. Oh, I can see this would be great. We want to go to cursor 2, okay, back. So cursor 2 is this one over here. You can zoom out a bit more. With our measure control here, give it a sec. All right, so, and this is why I don't like these screens. Now, if you end up with that, what we can actually do is drag the waveform back over here, and then stop that from, because this touchscreen's not turned on, that's right, Glenn. We can then grab our measure cursor and single shot it, so it only does one run. All right, to roughly there. Oh, it's pretty close. 0.75 hertz. Okay, so 1 over the time gives you that. Is that good? Everyone happy with that? Okay. What's the other way? I mean, all of you should have done electronics. So what's another way? And these scopes are also down in 10, 7, 22, and 23. What's the other way of determining frequency? There's two other ways actually. Yep. Press the measure button. Measure. Clear all measurements. Clear all. Add measurement, frequency, channel 1, add. There you go. Okay? That's whatever. I don't mind if you do it that way, I don't care. Okay? What's the other way of doing it? You can run the FFT. Anyone use FFT on these things? Alright. What's its problem? Yeah, I don't care about that. Okay, so FFT, source channel 1. Okay, so our center frequency is going to be really low. Let's go stop frequency. I don't know whether this is so low, it may not even do this. Let's wind this back down. Because it's 0.75 hertz, right? Of course, it's a screen. Stop frequency, let's make it, I don't know, 5. Clear. 5 hertz. And start frequency, yep, that's actually right, believe it or not. What are we seeing here? Oh, sorry, let me turn that off, just so you can see. Okay, that's the FFT. Makes sense. Why does that make sense? If I wind the stop frequency up, let's go up. Nope, doesn't like me anymore. Okay, it's such a low frequency, but what are we actually seeing there? If we get the cursors, right, measurement free, cursors, sorry, my eyesight would work, would be fantastic. Manual, thank you. Source is the FFT on channel 1. Cursors, we only really need X1. Okay. Back. All right. X1, please. Thank you. Don't do this now. Back. And we're going to measure. Okay. There's our first peak at 0.75 millihertz. So it's correct. What are all the others? Harmonics. Yeah. They're all harmonics in the spectrum. So digital is, what have we got? What are we actually sampling? It's a square wave, right? If you take a square wave, what's the frequency spectrum of a square wave? Everything. Yeah? And so you're ending up with harmonics in your spectrum. And they'll exist. I mean, it's going to get nasty with me. It won't like me doing this. Let's go all the way. Okay? This is where digital and comms and maths all come together for that sort of functionality. Do I want you to do that? No, but it's quite an interesting thing to see when you're actually working with these systems, is that you've got reflections and harmonics associated with your square waves and so on. Okay, is everyone comfortable with that? Any questions about that aspect? Do you want to we'll move to the UART? Okay, UART's really easy. Well, I'm going to say it's easy. On our board, now again, don't do this when it's plugged in. Make sure you turn it off. On our board, and I said I have the proper wires, the UART 3, where are we? That's the IO, ground power. Yeah, I thought we broke that out.
No, you see it.
Yeah, it is, yeah, UART 3, sorry, I should put my glasses on. UART 3 is right there, okay, which is this, right? So, we've got a TX and RX and a ground, so we want, get my trusty do not do this, plug that in, okay? And we get our scope probe again. Let's go on the RX pin, let's just see what that's been, okay, cool. We'll go on the RX pin. Now equally, ground is going to be that as well, so I can grab that. Cool, okay. Default setup. Okay, back to default setup. We know from working with before, 3.3 volts. Okay, so we're at 1 volt per division, that's fine. 100 mic there, let's bring the trigger up to somewhere around there. Okay, we know we're expecting what we're sort of expecting. Now on my PC, if I press the character, okay, we see something. Right, I'm just hitting key 0 on my computer. Now, what do you do in that instance where you see something and you've got a DSO at your whim? What can we do? Well, put it in single shot mode. There's your waveform. Okay. Now, we can zoom out, hit it in single mode again. I'm going to press the key 7. There's our serial transaction. There you go. Does that make sense to us? What have we got? Oh, that light. What have we got? What's UART comms? What's the bit order in UART? Topic 5, I think. Topic 6. Start bit, LSB first, stop bit. You can tell from here what the baud rate is as well, because you know that if you compare here and here, this is the shorter ones, right? Which is going to be period. Yeah, so straight away you can tell how fast the UART's running. So we can do the same thing. We can go into cursors again. X1's fine. Let's grab that. Let's grab. Sorry, I'm going to lean over this because I can't see it on the screen. We're going to grab that one. We're going to grab X2. We're going to go here. Okay, we have roughly 333 kilohertz, which is pretty close to 31,250 bits per second, right? Which is what the UART is. So we can tell straight away what the baud rate is. All right, you don't need to guess. Sorry, you guys probably can't see it. It is 33.33 kilohertz there, right? Okay, but you've spent all this money on a mega expensive oscilloscope. These ones do this. Serial, mode, UART, sorry. UART. Cool. Signals, channel 1's received. OS 1.02 is the threshold, don't care about channel 2. Settings. Framing, don't care about any of that. Bus config. 8 bits, no parity, baud rate. Oh, okay, cool. So let's set the baud rate. 31, okay. So, there's nothing there that matches our thing, but we have user defined. User defined, user board, clear 31.250. Done. Now what happens? If I press a key, all right, do we get a transaction? Let's turn the cursors off. So we can see, I want it in run mode, we've got a trigger. What else do we care about? Probably just that. That's run mode. Yeah, that's cool. So if we hit a key, right, so we can see a glitch there, right? If we zoom in on that, okay, we can see that we can get, now it's having an issue here because it can't actually decode what's going on. So if we go back to serial, here, okay, that's fine, that's fine, that's fine. That's fine, no problems. 8 bits, no parity, hide or high, okay, and LSB first. UR idles high, okay, single shot it, 72 ASCII. Sorry, 72 what's this one set to? Settings, hex, yeah, okay. 72 hex, which relates to the character, oh yeah, I pressed R, that makes sense, that's about right. So for example, if I now put this in run mode, if I put it in lister mode, window half screen, if I now press 0, 1, 0, no, it's not gonna do it for me, okay. Because it's still having, because it needs a time trigger. But effectively, what you can do is, because transmit's also not connected. You can use this, put it in single shot and type 0, which is 30 hex, okay, in ASCII. That's how you can use these instruments. Now you notice that it's also shifted this way. You can drag the waveform back so it can actually see what's going on there. And I imagine, yeah, it's just having a hard time because I don't have the other probes connected. But yeah, so you can see the behavior, all right? So when you get out to industry and your boss says, what's the first instrument you want? One of those. That'll save you so much time, okay? Does that all make sense? Everyone happy with that? Now, not every scope that you can get has those features or that level of protocol decode. The new ones do, but this has got a lot more. So this does like these do like canvas and all sorts of things. But being a Keysight instrument, it's a software unlock and it's about $3,000 per protocol. All right, so you do have to watch that when you go out to industry, they are expensive. But yeah, so that's how you can use the test instruments as part of your project and as part of debugging things like timers and so on, okay? Everyone good with that idea? Everyone happy? Okay, let's take a 5-minute break and we'll get into writing some code for today and looking at some simulation aspects, okay? All right, now for that ASCII thing that was pointed out,